Hello, and welcome to another session of SQL tutorial with DIHL Consult. In this session, we'll be looking at SQL joins. So an SQL join is a clause used to combine rows from two or more tables based on related column. It allows you to retrieve data that is distributed across multiple tables. So in previous videos or session, we've focused on a single table, but with SQL join, you can retrieve data from more than a table. So if you are faced with that requirement to extract reports with data distributed across various tables, you will need SQL joins to bring the tables together in order to retrieve your data. So let's look at the types of SQL joins. We have inner join, left join, right join, full join, Cartesian join, and self join. All of these we'll be demonstrating in this video. So inner join returns rows when there is a match in both tables. So the inner join will return records from, say for instance, table A and table B, where there are match between table A and table B. For left join, it returns all rows from the left table, even if there are no match in the right table. All of these will be demonstrated for proper understanding. The right join returns all rows from the right table, even if there are no matches in the left table. Full join returns rows when there is a match in one of the tables. And Cartesian join, which is also cross join, returns the Cartesian product of the set of records from the two or more joined tables. And when we look at self join, you see it's used to join a table to itself, as if the table were two tables, temporarily renaming at least one table in the SQL statements. All of these will be demonstrating in SQL Developer Platform for proper understanding. So why SQL joins? One, it's for data integration. Two, for complex queries. So you use SQL joins in complex queries. Then 3, for efficiency. 4, for consistency. And then 5, is for flexibility. So when we look at data integration, SQL joins allow you to combine data from multiple tables based on related columns, providing a unified view of the data, as I explained earlier. Then 2, in terms of the complex queries, they enable you to perform complex queries that retrieve data from multiple tables simultaneously, which is essential for generating comprehensive reports and insights. Then in terms of the efficiency, by using SQL joins, you can filter, aggregate, and sort data directly within the database, which is usually more efficient than fetching data separately and then merging it in your application. Then in terms of consistency, joins help maintain data consistency and integrity across tables by using foreign keys and ensuring that related data is accurately linked. And then in terms of flexibility, they offer various types of joins, as we highlighted earlier: inner, left, right, full, and cross, to suit different querying needs, providing flexibility in how you return and manipulate data, how you retrieve and manipulate your data. So we'll be demonstrating SQL joins in Oracle SQL Developer for proper understanding. A primary key is a unique identifier for a record in a table. It ensures that each record can be uniquely identified, preventing duplicate entries. Every table can have only one primary key, which consists of a single column or a multiple columns. A foreign key is a field or collection of fields in one table that uniquely identifies a row of another table. It establishes a link between the two tables and enforces referential integrity by ensuring that the value in the foreign key column matches a primary key value in the related table. SQL joins using primary keys and foreign keys to combine rows from two or more tables based on related column, allowing the retrieval of related data in a single query. So we'll be demonstrating SQL join in SQL Developer Platform. That's Oracle SQL Developer Platform. For demonstrating inner join, we'll be looking at two tables. One is the customer table, and then the other is the transaction table. Firstly, let's view our customer table. I'll do that by saying select all from customer. That's the name of the table. I run the statements. We can see the columns in the customer table: branch ID, customer number, first name, last name, date onboarded, nationality, and so on and so forth, with all the other details for customers. Looking at the customer number in this particular table, the customer number is the primary key. That is the unique identifier. So primary key in a table is the unique identifier for that particular table. So let's check our transaction table. We select all from transaction. Because of the earlier statement, so I'm going to highlight this before I hit the execute button, run statement button. I run this, going through the table: transaction date, transaction ID, customer ID, transaction currency, and so on and so forth. So if you take your time to study this particular table, you will see that in the customer table we have customer number. In this table we have customer ID. So we are going to be using the customer number in the customer table to link the customer ID in the transaction table. So in this transaction table, the customer ID is the foreign key. So it's what we are going to use to link our customer table. So having said that, let's take, for instance, I want to select the following columns. So in my customer table that showed earlier, select all from customer. I run this, So let's assume I want to select the branch ID. Select branch ID, customer number, first name, last name, email. We have a column. I scroll down, we have a column that is for email, phone number, let's say that's all we want to select from the customer table. Now let's see the transaction table again. Select all from transaction. I need to highlight this because of the other statements on the portal platform. I execute this. We can see the columns in the transaction table. Now let's say I want to select transaction date. It says if the customer carried a transaction on what date or the date the correct transaction occurred, then transaction amount. So in this case we assume they are all in the same currency. So transaction amount, transaction remark, which in actual fact is a narration, and then transaction status. There's a column, transaction status. So we can see pending, failed, success. So let's assume we are going to be focusing on successful transaction. So it's a transaction status. Now remember the two tables. One is from customer, our branch ID, customer number, first name, last name, email, phone number are all from the customer table. And then using our inner join command, inner join transaction, that's the table we want to join, inner join transaction on customer, that's the table, dot customer number, referencing the table and the column, equals transaction dot customer ID. In our transaction table, as we have the customer number in the customer table, we have customer ID in the transaction table, which is the foreign key that we use to link the customer number, the primary key in the customer table, the unique key. Okay, having done that, and then like I did mention that we'll be looking at transaction status, where transaction status is success, and then I can now put the condition where transaction status equals as specified in the table, in the column rather, success. So if let me drag this down a bit, if I execute this, I have to highlight it because of the other statements above, and then hit the run statement button. Okay, I can see there's a misspelling of a column, which is this one. It's good we have that error, so you'll be able to spot it. It could happen. If I highlight this again, we can see our inner join. I return the record as specified, and for all successful transaction. Let me see. Rows 6730 rows. Now that is demonstrating our inner join, and in this particular script, this type of inner join is called the explicit inner join. Write that out. Explicit inner join. Using the same script or statement, if I copy this and bring it down, there's another type of inner join that is commonly used, and that is where we say, having selected all the columns as shown here, we're not saying from customer and the other table transaction. So not to create any confusion, let me remove all this at first. So from customer and then transaction. Now we now use our where clause to do the joining, where customer dot customer number equals transaction dot customer ID and transaction status equals success. So this will return the same output as the first script that I made reference to as the explicit inner join, this one, and this we can call implicit inner join. It will return the same results, but in this case we are using our where clause to join the two tables. So if I highlight this and run, so let me do a quick count. You can see 6,730 rows as shown in the first script, and that is our inner join being demonstrated using customer and transaction. So it will return the rows where there are match between the two tables. Okay, thank you. If you made it so far, thank you for taking the time to be with me on this session, and I hope to see you in the next session where we'll demonstrate the other type of SQL joins.